Hey, in this video we're going to learn how to graph rational functions. At the end of the video you should be able to graph rational functions. Let's begin with your parent function of the rational function. This is your parent function and this is your transformation guide. What do the following represents? A represents the vertical stretch or compression, H is the horizontal translation, and K is the vertical translation. That is, if we are going to base the transformation on your parent function. Your parent function graph should look like this. It's a perfect symmetry wherein the graph appears on quadrant 1 and quadrant 3. Now, first, before we graph, let's recall some terminologies. We have asymptote. It's the line where a graph approaches, but it does not intersect. There can be vertical asymptote, horizontal asymptotes, and sometimes we may encounter slant asymptotes. Given a graph, your vertical asymptote, of course, should be here, wherein the graph tends to approach it, and then your horizontal asymptote should be located here. If we're going to look for the value or the location, vertical asymptote is located at x is equal to 2. The vertical asymptote is located at y equal to 0 because it intersects at 0 of y-axis. Let's have your first example. This is based on the parent function. So given the parent function, based on your formula, now what is the transformation? Actually, the parent function should go down 3 units. To show the transformation, the parent function should go down 3 units. This point will go 1, 2, 3, and it should appear here. And there it goes. Okay. Next, we can now identify or locate your vertical asymptote. Your vertical asymptote actually did not change. It's still in the middle. It's at x equal to 0. And your horizontal asymptote has changed. It's actually on your y is equal to -3. If we are going to determine your domain and range, domain are the values of x allowable in your function. Actually, it does not allow x because it does not have x, because if we have 0 here, it will be undefined. So all real numbers except 0. Next, how about range? Well, looking at your graph, it does not allow that the y is equal to -3. Therefore, range should be all real numbers except -3 because looking at the graph does not allow y values of 3 for the function. Okay. Now, your rational function cannot be as simple as your parent function. A regular rational function will have polynomials on the numerator and polynomials on the denominator, so we need to follow a more clear steps or guide when graphing a rational function. And so here it is. First and foremost, you need to consider to factor completely your numerator and denominator. Then determine if there is a vertical asymptote. You just simply set denominator equal to 0, and it is stated as an equation as x is equal to the number. Remember, vertical asymptote is based on the denominator that is not cancelled. The vertical asymptote are the domain exclusion. So when you are asked of the domain, you go back to the value of vertical asymptotes. Those are the not allowed value of domain. Next, determine your horizontal asymptotes. Compare the degrees of the numerator and the denominator. That's the basis of your horizontal asymptotes. We will have a review on this as well. Number 4, probably the roots can help you also determine the graph of your rational function. You just simply set the numerator equal to 0. What is the another name for the x-intercepts? It's actually the roots. What does it mean on the graph? Well, it is where the graph crosses the x-axis. So this also helps us on graphing. It is the intersection of the graph on the x-axis. Lastly, you need to make sure determine if there is holes. Look at the factors that are common to the numerator. It is actually the common between numerator and denominator, the basis of the holes, and just set that factor equal to 0, and so you have value of holes. Remember, vertical asymptotes are based on the factors in the denominators that are not cancelled. Holes are based on factors that are cancelled, both on numerator and denominator. We are now ready to graph a rational function. Nope, we are going to review your horizontal asymptote. So there are 3 cases for your horizontal asymptote. It is based on the degree. If the degree of the numerator is lower than the degree on the denominator, such as here we have 1 degree, the denominator has higher, which is 2, your horizontal asymptote is y equals 0. The second case, if the degree is equal, see, we have here 1 over 1. You just divide your leading coefficient. The leading coefficient is 6 and 3. And you're just going to divide them. That's why if this is the given, your horizontal asymptote is 6 over 3, which is 2. Lastly, if it's reversed, the degree on top is higher than the degree below, then there is no horizontal asymptote. Okay? And I guess we are ready. This is your regular rational function and how to graph it. Let's say you're given f of x is equal to x plus 1 over x minus 1. Let's start with identifying parts of the graph. First, what is your vertical asymptote? It is based on your denominator. It's actually 1. Because you're going to just equate your denominator into 0, so it's positive 1. Your horizontal asymptote, it's actually, this is your vertical asymptote. Actually, it's based on your value of your degree, 1 over 1, since they are the same. So you have 1 divided by 1, then your horizontal asymptote is 1. That was the case 2. And so your horizontal asymptote appears here. These are the lines, the imaginary lines that the graph will not intersect. It will just seem to approach when it extends to infinity, but it does not intersect it. Now, roots is based on equating your numerator into 0. Therefore, the root is equal to, if this is x plus 1 equate to 0, then root is negative 1. It means the curve intersects on negative 1. Do we have a hole? Since we did not have a cancelled factor, then there's no hole. Do we have a y-intercept? Well, y-intercept is found if we put 0 on x. So if x is 0, you have 1 divided by negative 1, so it's a negative 1. It means the curve intersects at negative 1 of y. And these are all the hints of your graph, but actually, this is good enough hints. We can now presume that the graph actually tends to approach here and here. And so it is a reflection also on the other side. Okay? Actually, there is the actual graph on the PowerPoint. There it is. Let me erase the draft. And that is the accurate graph of your given function x plus 1 all over x minus 1. Now, if you're being asked with the domain is based on the vertical asymptote. All real numbers except 1. Range, all real numbers except positive 1. As you can see, on y, it does not allow the value of positive 1. Domain is all real numbers except 1. Range are all real numbers except 1. Okay, now let's have another example. If you're given a function x squared minus x minus 6 all over x plus 1, remember step 1, factor your given rational function. And then let's start identifying parts of the function. What is the vertical asymptote? Since we didn't have a cancelled factor, it is based on the denominator. You just equate it to 0. So you have x plus 1 is equal to 0. Therefore, your asymptote is -1. Your vertical asymptote is -1. And so it should appear here. There we go. Horizontal asymptote is based on your degrees, 2 over 1. Since the degree is higher than on the numerator than the denominator, there is no horizontal asymptote. Okay, it means it's there is no horizontal inclination. Roots are based on the numerators. You just equate the factors into 0. So your first root is on +3, second root is -2. And so you have 3 and -2. That is where the curve will intersect on the x-axis. Do we have a hole? Since there's no cancelled factor, no hole. Do we have a y-intercept? Well, we can find y-intercept by substituting 0 on the x's. So if this is 0, 0, 0, -3 times 2 is -6, divided by 1 is -6. Y-intercept is -6, so there's a point here. And this is already enough. If you notice, this is a complete intersection of this one. So if we're going to draw an x, this is just a guide. So the graph tends to go here. Okay. And there's actually graph on the PowerPoint. Okay. Those values were already enough as your hints of your graph. Or if you want, you could actually pick points on each of the x and x-axis. Let's say if you picked 1, your value is supposed to be the result of solving of your function should be -3. So that should be your second point. If you want to pick points, that gives you more hint on your graph. Okay, since we are done with graphing, we can now answer the question, what's the domain? Well, the domain will not only allow -1, therefore all real number except 1. Range, since there's no horizontal asymptote, looking at your graph, it did not have any, it did allow all values of y. So therefore, range is actually all real numbers. Okay, let's have another example. It's gonna get complicated. So graph your given function x squared minus 3x plus 2 all over x squared minus x. Start by factoring it first. It should have a factor of x minus 1 multiplied to x minus 2 all over x times x minus 1. Then we have a cancelled factor. Prepare your graph. We have to leave it there, the x minus 1, because we still need them on some parts of the graph. What is your vertical asymptote? Well, since x minus 1 is cancelled, so it's only x that's gonna be the basis of your vertical asymptote. Vertical asymptote is based on the uncancelled denominator factor. So x is equal to 0. Therefore, your vertical asymptote is on the y-axis. There. Your horizontal asymptote is based on the degree. Since they have the same degree, therefore, it's going to be leading coefficient 1 divided by 1, and it is 1. Because based on case B, when the degree is the same, divide the leading coefficient of the numerator, which is 1, divided by the leading coefficient of the denominator, which is also 1. So you have 1. And so a flat line, which is your horizontal asymptote, appears on the intersection on y-axis at 1. What are the roots? Well, equate your numerators into 0. So your first root is 1, second root is 2. So a root will appear on 1. No, your root is only based on the uncancelled factor, so it's 2. Sorry about that. Next, wholes. Do you have a wholes? Yes. -1. So your root is only based on the uncancelled numerator. Your wholes is based on the cancelled factor, which is -1. We will equate it to 0. So your whole is on +1. But it's not the same level here. It's on 1, but not here. How do you know if it's up or down? Well, you need to substitute 1 on the uncancelled factor. So if this is 1 and this is 1, 1 minus 2 is -1 all over 1. The whole, although it's +1 on the x-axis 1, but the actual location is at y1, x1, y -1. So your whole is actually here. There it is. Y-intercept. What is y-intercept? Well, we need to substitute all x's to 0. And if this is 0, 0, 0, well, actually, since 0 will make it undefined, actually, the line, as you can see, it will not intersect on the y-axis, so there is no y-intercept. But I guess it's already clear. It means that the graph seems to approach this horizontal asymptote and seems to approach this vertical asymptote. And this is the reflection on the opposite diagonal axis. But remember, if there is a hole, you need to draw the hole when you do your manual drawing. So let me clear it up, and actually here is the more accurate graph of the function x squared minus 3x plus 2 all over x squared minus x. If you're going to be asked what is the domain, well, what values of x it does not allow, value of 0, and also it does not allow the value of 1, and x is also not equal to 1 because of the hole, because it will make it undefined. So there are two exceptions: all real numbers except 0 and 1. The range, it will not only allow the value here on 2, on 1, sorry. It will not only allow value of y on 1. All real numbers except 1 on y. Okay, and that's it. I guess we have the last example. Graph the function 2 times x squared minus 9 all over x squared minus 4. First step, factor everything. This is the correct factor. I know it should take a lot of time. You're lucky if the given is already in factored form. Next, prepare your graph and identify the parts of your graph of the rational function. Vertical asymptote, we didn't have any cancelled parts, so there are two vertical asymptote because vertical asymptote is based on the uncancelled factors in the denominator. So if we equate the denominators equal to 0, your vertical asymptote is +2 and -2. So therefore, when you draw your guide, there is vertical asymptote on positive 2 and negative 2. Your horizontal asymptote says that if the degree is the same, you just have to divide the leading coefficient. On top there's 2, on the denominator there's 1, so it's 2 over 1. No, yeah, it's 2. So a imaginary line appears horizontal that intersects on 1. Roots. The roots is based on the factors x plus 3, x minus 3. You just equate them to 0. So first root will appear on positive 3, which means there's an intersection of positive 3 and negative 3. Holes. Do we have holes? Since we didn't have a cancelled factor, there's no hole. What about y-intercept? Well, you just plug in 0 on all here and then solve. So 0 plus 3 is 3. 0, so 3 times 3 is negative 9, times 2, negative 18. 2 times 4 is negative 4. Negative 18 divided by negative 4 is positive 4.5. And that will be your y-intercept. So we can have a point here that it should be a little higher, 4.5. And we are now ready to draw your graph. Supposed to be, it will glide and seem to approach your asymptotes, but it will not intersect. This on top does not go down. It should be in opposite direction. It's just the way it behaves. Okay? And this is the accurate drawing of the graph. Let me clear so it's neat and clean. And that's the graph of the function 2 times the binomial x squared minus 9 all over x squared minus 4. Here's the most tricky part. Domain. What does it not allow? All real numbers except positive 2 and negative 2. Because it does not allow 2 and negative 2. What about range? Well, the values of y allows less than 2 and greater than 4.5. It should be or. Y should be less than 2 or greater than or equal to. I put equal because 4.5 is part of the value of x, but 2 is not. It's just less than 2. Okay? To summarize, when graphing rational function, always remember step 1, factor completely. And then step 2, determine the vertical asymptotes. It is based on the uncancelled factors. Uncancelled denominators. Step 3, determine the horizontal asymptote. Remember, there are 3 cases and they are based on degree over degree. Step 4, find the roots. You just set your numerator factors equal to 0. It will also give you hints of the points where the graph intersects the x-axis. And lastly, most importantly, if there is a hole, there is a cancelled factor, because holes are based on the cancelled factors. Please do note also and draw an unshaded circle for the existence of the hole on the rational function. If you need to review, you can watch this video again. Thank you.